This video is regarding Introduction to Data Structures. Before proceeding towards actual concept of data structures, let's first discuss the terminology associated with data structures. You are having the concept as data, information and knowledge. Let's try to understand the difference between these terms. Data is defined as facts or figures or information that is stored in or used by a computer. Basically, data is raw or it is unorganized and it needs processing, whereas information is a processed data. And information is the data that has been converted into more useful and intelligible form. This information is organized and it can be used in the decision-making process. So you can say that it is the refined form of data that is useful to understand the meaning. Now, after information is being gained, you apply this information and that becomes knowledge. So, knowledge is relevant information that helps in drawing conclusions. To understand this basic difference between data, information and knowledge, let's take a simple example. If I give you some data as 5, 10, 15, 20, 25. Now if you look at this, it's just raw data or some numbers or figures. Now if you give this data to your brain processor, it will be processing this data, it will be organizing it in a more intelligible form, and after processing, it will understand the meaning that these are multiples of 5. So then it becomes information. And when I give you any mathematical problem and you use this multiples of 5 in solving the problem, it is the application of your information which becomes knowledge. So you are having some raw data. This raw data when processed becomes information, and information when it is being applied becomes the knowledge. That's the basic difference between data, information and knowledge. Then associated with this data, information and knowledge, you are having a concept called as data type. Data type represents what kind of data is being stored into it. Basically, it is a classification identifying the type of data. It determines what values a particular type can take. Say for example, it can be an integer data type which takes numerical values, it can be a character data type, or even it can be a string data type, or it may be a boolean. So these are various data types which represents what kind of a data will be stored into it. Then if you're organizing this data, storing this data, it becomes a data structure. So a data structure is defined as a way of storing and organizing the data so that it can be used efficiently. In association with data structure, you are also having a concept called as abstract data type. It's a mathematical model that specifies the logical properties of data type. So you can say it's a collection of values and a set of operations which are being performed on those values. So whatever for any particular data structure, you can define its abstract data type as what values will be present into it and whatever are the set of operations that will be performed onto it. It hides the implementation details of how these operations will be performed on the values. So it just gives the functionality of the operations and hides the implementation details of it. So that is the abstract data type. Now with this basic introduction to the various terminologies used, let's have a look at the data structure. A data structure is basically divided into built-in data structures and user-defined data structures. These built-in data structures are also called as primitive data structures, and user-defined data structures are also called as non-primitive data structures. So built-in data structures are basically the data types which stores a particular type of data into it. Say for example integer, float, character, pointer type of data. Whereas user-defined data structures are arrays, lists and files. These lists are further classified as linear lists and non-linear lists. Linear lists are categorized as stack and queues depending on their functionalities, whereas non-linear lists are further classified as trees and graphs. So this is an overall picture of different types of data structures. With this, now let's have a look at the classification of data structures. As specified, the data structures are primitive and non-primitive data structures, linear and non-linear data structures. Along with that, there is alternative classification of data structures called as static and dynamic data structures. And there is another classification of data structures called as persistent and ephemeral data structures. Now let's have a look at each of these classifications of data structures with their examples. Primitive and non-primitive data structures. Primitive data structures are the basic data structures that are directly operated upon by the machine instructions. They represent the standard data types of any programming language. As specified, these are the built-in data types and they store a particular type of data into it. So they can be integer, character or string. Non-primitive data structures are developed using these primitive data structures, and these non-primitive data structures have specific functionalities. So they are storing the data as well as they are having some particular operations being performed onto it. Say for example, arrays, lists are the non-primitive data structures. These non-primitive data structures are further classified into linear data structures and non-linear data structures. Linear data structures are the data structures in which the data elements present into it are organized in a sequence and they form a linear series. And these data elements are traversed sequentially one after the other. The examples of linear data structures are arrays, linked list, stack and queue, in which the elements are organized one after the other. Whereas in case of non-linear data structure, a data element is connected to several other data elements. So it may have a hierarchical relationship. As such, there is no sequence in the data elements. The data elements so cannot be traversed in a sequential order. The examples of non-linear data structures are trees and graphs. Apart from this, there is alternative classification of data structures as static and dynamic data structures. Static data structures have a fixed memory utilizations. For the static data structures, whenever the data structures are being defined, the memory is being allocated for it and is being used, and the memory is fixed. So at runtime, you cannot alter the size of these data structures. Whereas in case of dynamic data structures, at runtime the memory can be allocated as per the requirement and used. And if it is not being required, also the deallocation of memory can be done. So dynamic data structures are more memory efficient. The memory size is not fixed. It is as per the requirement of the application or the user that memory will be allocated and deallocated. The classic example of dynamic data structure is the linked list, in which nodes are being created as per the user's requirement, and after its use, the nodes are also being deallocated or freed or removed. So that is the classification of static and dynamic data structures. Then there are persistent and ephemeral data structures. Persistent data structures are the data structures which retains their previous state. Say whenever the operations are being performed on the data structures, whatever are the states that are being undergone by the data structures come up again in the life cycle of that particular data structures. So that is called as a persistent data structures. The classic example of persistent data structure is stack. But apart from that, you can also implement a persistent binary trees, or you can make even the other data structures as persistent by retaining their previous state. Then there are ephemeral data structures which does not retain their previous state, like the queue. Whenever operations are being performed on the data structures, it undergoes a change in the state and the previous states are never again recalled in their life cycle. So that is the ephemeral data structure. So these are the different types of classifications of data structures. The references for this videos are as follows. Thank you.